Hey guys, it's Mrs. Ross. I am here for Algebra 2 to go over 9-6 and 9-7. I know that we moved the day, so sorry if you're listening not live. These are two great sections to do online. They're also pretty quick sections, so I just wanted to do those while we were online here. And we're going to wrap up Chapter 9. Okay, so we have done a lot of work in Chapter 9. We've talked about the distance and midpoint formula. And then we learned a lot about a lot of different equation types in Algebra 2. So we talked about parabolas and some properties of parabolas. We talked about circles, right? We've talked about ellipses, which are kind of like circles, but they're squished. And we have our two focus point, or foci, that are equal distance on every point of the ellipse. And then we have our hyperbolas, which are I'm going to go ahead and close this. Our hyperbolas, which are, oops, sorry about that. Oh, goodness. Okay. Hyperbolas are actually a lot like ellipses, but they're actually going in the other direction. Or they also share a lot of things with parabolas, right? It's like two parabolas. So all of those should be things that we've talked about before you've done your homework on. And we just have these last two little sections to kind of build on. So all the way up 9-1 through 9-5, I think I mentioned in every section. What was nice is that for all of these, you can see them listed here: circle, parabola, ellipse, and hyperbola. We assumed that the center was always at 0, 0, always at the origin, right? And so 9-6 just shows you what happens if we actually move our circle or move our parabola not with a center at the origin. And so you'll see here that, it's right from your book, that for all of these equations, we have our standard equations, and then we've put in this values of h and k, where h and k represent where the center of our conics, which are our circle and our ellipse, and our vertex of our parabolas. So basically h and k in all the sections before this, we said were 0, 0. So you'll see this equation here. We have x minus h squared plus y minus k squared equals r squared. If you remember, let me open this up here. If you remember, when we learned about circles, our equation, we just took out this h and took out the k, and it was x squared plus y squared equals the radius squared. And the reason we could take them out is not because we just could, is because we actually had our center was at 0, 0. So that's what our equation looked like. Okay. The same with our parabola. The equation of a parabola, we had this was 0 and this was 0. So the equation of the parabola was y squared equals 4 times p times x if it was horizontal, or x squared equals 4 times p times y. All right, so things are shifted. Same with the ellipse. If you take out the h and the k, you have x squared over a squared plus y squared over b squared equals 1. And then we add the h and the k in to change our center. So I can obviously scratch through all of these, but that's not going to help you out a whole lot. What I'd like to do is really what we're doing is we're going to graph our different equations, and 3 through 13, we're going to graph our equations, and we're going to identify important characteristics of our equations. So you should have these at the bottom of your notes. The first one is x plus 1 squared plus y minus 3 squared equals 4. So just looking at this, I know that before even graphing this, this is going to be a circle because it's the equation of a circle, and it's not going to be at the origin. So if I flip to Desmos, I had it typed in like this, but I think I'm just going to type it in like the equation. So we have x plus 1 squared, y minus 3 squared equals 4. Okay, so you can see that we have a circle, right? Which is not surprising. But the circle, all the circles that we did before were around the center here. So this is what our circles would have looked like before. Take out the 3 and this. Okay, so this is what our equation looked like before, around the origin, and we have plus 3 and minus, or plus 1 and minus 3. So let's see what each of these did. When I add plus 1 to my equation, I actually shift my circle to the left by 1. Okay, so it was here. I add 1, and my equation actually goes to the left. So remember, it kind of feels opposite. When you add to an x value inside the equation, it shifts your graph left. And when you subtract, it shifts it right. Okay. Now I'm subtracting 3 from y, and you can see here my circle goes up to up 3. Because I'm subtracting, it goes up 3. Okay. So here's my original. Here's my new. So basically what I want you to do is to be able to graph these, which you guys all have a graphing tool. But then we also have to identify a couple of our important characteristics. So what I'm expecting for that is I want you to be able to identify that the center of your circle is now at -1, 3. Okay, so I want you to be able to identify the center of my circle is at -1, 3. Okay, and then I also want you to be able to identify that the radius of your circle is 2. And this is pretty easy. You can just count. It's 2 here, 2 here, 2 here, 2 here. You can also go back to your original equation, right? And 4 still is your radius squared. So 2 squared is 4, so that's my radius. Okay, so that's what I want you to be able to do for a circle, to be able to identify, oh, okay, by adding 1, I shifted my graph to the left by 1, okay? And by subtracting 3 from y, I shifted my graph up by 3. All right, so that's a circle. Let's check out a parabola. Yep. So this is example number 2. We have x minus 2. Oops, got a bunch in there. I'm going to just start with my parabola without. I know what I'll do. I'll put 0 in. Okay, so oops, I didn't want to do that. I want to put 0 there. Okay, so what I did is I'm taking example number 2 from your homework. Not on that page, here, right here. Okay, and I'm graphing it without moving the vertex. So because this is 0 and 0, the vertex is at 0. Okay, when I subtract 2 from x, remember, it's opposite of what you think. So when you subtract, you actually go to the positive 2. Okay. And then if I add 3, that means my graph is going to go, if I add 3 to y, means my graph is going to go down the opposite direction. So I would want you to be able to graph the parabola and then identify that your new vertex is at 2, -3. Okay. You can also find the, sorry, I'm having a little mind blank. You can also find the focus point, right? So 4 times p equals 8. So that means that p equals 2. So instead of your focus point being at 0, 2, your focus is going to be 2 spaces up. So your focus point is actually going to be at 2, -1 for this. I'm not expecting that level of detail. I mean, the book might have that included, but for you guys, I want to see how the vertex gets translated. Okay, so that is a parabola. All right, example number 3. We have, again, I'm going to x plus 0, if I can type correctly, squared, minus I minus 0 squared divided by 4. So I'm just typing in example number 3 here. Equals 1. There we go. Okay. So again, this is a hyperbola, right? Its origin is at 0, 0. So you can see that the two focus points are equal distance away at -1 and +1. If I then change my equation and I add 3, so I'm adding 3 to the x, which means it's going to shift my graph to the left by 3. So do you see that? This was before. Actually, I'll copy and paste it. So by adding 3, I shift my graph to the left. Okay. And by subtracting 4, I shift my graph up by 4. Okay. So this is a little bit hard to see because they have intersection points. I'll turn this off. So this is where you have to be a little smart because they will not actually tell you what the vertex are, but you can look and see here that that my vertex is at -2, 4, right? Because I've gone from my vertex was over here. Sorry. My vertex was here at +1, and now it's at -2. Sorry, it's hard to hear. Okay. So it's gone to the left by 3 spots. It's also gone from 0 to +4. Okay. This vertex has gone from -1, right? And it's shifted left by 3, so now it's at -4. And the y value is at +4. So I just want you to be able to identify those vertex for that. Okay, and then last up, we have our ellipse. So remember, you start off the equation like that, and then we will have okay, there's our nice ellipse. Again, the origin is at the center. Okay, if I subtract 2, that's going to move my ellipse, the center of my ellipse, to the right by 2. Okay, so it moved my center of the ellipse to the right by 2. And if I also subtract by 1, I'm going to move my center of my ellipse up by 1. So the new center of my ellipse is actually going to be at, it's really hard to see, it's going to be at 2, 1. This is where it's at. Okay. But remember, with an ellipse, the important parts that we want to identify are the major, make sure I'm saying it right because my brain, major vertex and minor, or major, yeah, the vertex and the covertex. I apologize. Okay. So it's kind of, actually, it's undefined on here because of the way this is written. But the vertex is actually going to be at 6, 1 before it was at 4, 0. So you can see that we went to the left, or sorry, to the right 2. So from 4 to 6, and we went up by 1. So we have a vertex at 6, 1 and -2, 1. And we have our covertex at 2, 4 and 2, -2. And that just has to do with how Desmos is graphing and in the equation. Okay, so that is 9-6. Again, quick, easy section. I think that took less than 20 minutes to do. Okay, and then the last section is solving quadratic systems. So let's talk about that. Again, we're going to be pretty graphing heavy with this, so this is a perfect section for it. If you have these quadratic systems, so if you have a circle, parabola, ellipse, hyperbola, and you want to solve the system, the easiest way to be able to solve the system is actually going to be by graphing. So for example, here we have number 1, we have a circle, has a radius of square root of 13, and then we have a line. So if I want to figure out what makes both true, my easiest method is going to be, so I have x squared plus y squared equals 13, and I have y equals x minus 1. I'm going to graph each of those. X squared plus y squared equals 13. Again, square root of 13 is that. And then I have a line that is y equals x minus 1. Okay, so if I wanted to solve and find what makes both of these true, they're both going to be true at the intersection points. So one possible value is x equals 3, y equals 2. And another possible value is x equals -2, y equals -3. So pretty easy, right? Let's look at number 2. Number 2 is, I think, an ellipse and a line. So let's see what makes both of those true. So we have x squared plus 8y squared minus 4 equals 0. That's an ellipse. Or you could write this as equals 4 if you wanted. Okay, that makes a little more ellipse-like equation. And then we have a line, y equals 2x plus 7. Okay, so we have an ellipse and a line. Are there any solutions that are true for both of those? So no solution that's true for both of those. Okay. So I don't think I need to keep doing the examples. If you, for some reason, would have, I don't think this is in the homework, but 2, 16, 8. So if I had these two equations and they were on top of each other, then we would have infinitely many solutions, right? So you can have wherever they intersect is a solution. Sometimes you won't have any intersections like that last example, so there's no solution. Sometimes you might have infinitely many solutions. Okay, the last one that I wanted to show you, I'm not going to do 3 and 4. Basically, you just plug it in and find out where they intersect, is what happens if we can't use a graphing tool, or we're asked to not use a graphing tool, to instead solve by substitution. So this is just kind of good review. If we have y squared minus 2x minus 10 equals 0, y equals -x minus 1. Well, nothing is preventing you from graphing it first, just to kind of get an idea of what you're looking at. So let's see. We have y squared minus 2x minus 10 equals 0. This is going to be a parabola because we have an x or y squared term and an x term. And our second one's going to be a line. So y equals -x minus 1. So we do have some solutions, so that's good to know. And they look like they're whole number solutions, so that's good to know. So let's actually see if we can figure out the graphing solution, right, by doing some algebra. Okay, so substitution means that we're going to substitute one equation into the other equation. Okay, so this should be review for everybody, but in case it's not, we'll kind of start from the beginning. So if we have y equals -x minus 1, that's one equation, and this is our second equation. We want to find out what's true for both. So we have two equations and two variables. We have x and y are our variables and two equations. If we can put this into this equation, what we can do is we can get rid of the y's and only have x's. So we can have one equation with one variable, which we know how to solve. So that's what we're going to do. I'm going to color coordinate a little better. I'm going to call that one green. This one red. It's like Christmas, right? So what we're going to do is we're going to take this red equation, and I'm going to rewrite it here. Minus 2x, hopefully I can write it, minus 2x minus 10 equals 0. But I forgot the y squared part, right? For y squared, I'm going to put in -x minus 1. Okay, that's going in for my y. And then I need to square it because that's what my equation says. It's y squared minus 2x minus 10 equals 0. Okay, so this is a 10, not a 18. Sorry for the crazy number. 10, there we go. So what I need to do then is I need to simplify. What you'll notice by substituting the y into this equation is that this equation only has x's now. And I know how to solve for x's, so that's good, right? So we want to FOIL this, right? And when we FOIL it, we get first is negative x times negative x, so we get x squared. Then we get x plus x, so we get 2x, right? Plus 1. I'm doing my foiling here kind of quickly. So first term is negative x times negative x, x squared. Then we have negative x times negative 1, which is x, plus negative x times negative 1, which is x, so that's 2x. And then the last term is negative 1 times negative 1, which is positive 1. We have minus 2x minus 10 equals 0. Sorry for my crazy numbers here. I'll try to be better. Okay, so 2x and negative 2x cross each other out. 1 minus 10 is negative 9. So we have x squared equals 9. And if I take the square root of both sides, I get x equals plus or minus 3. Okay, so x could be plus or minus 3. I'm not quite done yet because I need to know what the y's are for each of those. So if x equals positive 3, okay, and I go back and I plug that in up here, x equals positive 3, that's negative 3 minus 1, which is negative 4. So if x equals positive 3, y equals negative 4. And if x equals negative 3, then it's negative negative 3. So positive 3 minus 1 is 2. So negative 3, 2. So then if I go back and see, I should have a solution at 3, negative 4, and negative 3, 2. So negative 3, 2, and 3, negative 4. So that's how we would do it if we didn't use a graphing tool. I think that should be enough for you guys to get through your homework. If you have any questions, ask me on Monday, and I will be sending out your test. Hope you have a good weekend. Bye, guys.